Hi everyone. What I want to do in this video is explain how urine is concentrated in the nephron, really how filtrate is concentrated, and then once it is, it becomes urine and can no longer be modified, so it stays concentrated. First, let's reorient ourselves or orient ourselves to the nephron itself. And as I always emphasize, you really want to think about the nephrons having two functional parts in the sense that you have the left half of this picture, or the first half as the filtrate flows, that is the same all the time. The physiology is the same all the time and is not modulated by hormones that signal the state of the body with regard to dehydration, osmolarity of the blood, and so on. So the loop of Henle is always, as I explained in my other video, setting up the conditions under which urine could be concentrated. Whether it actually is or not depends on what happens in this second half of the nephron. The distal half, the distal tubule, and the collecting duct, those are the regulated parts of the nephron, the parts that variably reabsorb salts and water in response to conditions in the body and the hormones that signal those changes in conditions. Now, when you think about the loop of Henle, you have to remember, again, as I talked about in my other video, that it creates a high osmolarity not just in the tube itself, but in the interstitial fluid that surrounds that tube. And so the fluid is then contacting not only the loop itself, but also this collecting duct that dives down deep through the medulla of the kidney. If the collecting duct ran off to the right in our picture here, urine could not be concentrated. But in fact, it comes down deep into the medulla and therefore into the part of the nephron, or the fluid around that nephron, that is highly concentrated, that has a very high osmolarity. And you can see this in the indication on this figure. The renal cortex, the outer surface or the outer section of the kidney, the more superficial section, is isoosmotic to plasma at 300 milliosmolar. And the renal medulla, as it says here, becomes progressively more concentrated so that at the deepest part of the medulla, we have the maximum concentration of fluid. So now, this is the regulated part of the kidney, right? So whether you reabsorb a lot of water and make a concentrated urine through reabsorption in your collecting duct depends on your state of hydration, so and other things. But if we think about, what if you were very hydrated, or whatever animal we're speaking about, had a dilute urine, perhaps you just drank a bunch of water, so your urine is very dilute, your urine will be very dilute because your blood is relatively dilute. So as the fluid comes out of the distal convoluted tubule, whose function we're not really talking about here, it's quite dilute. In fact, it's even more dilute than when it came out of the proximal convoluted tubule. It's sometimes is as low, as shown here, as 100 milliosmolar. So it's actually more dilute than the blood itself. If you are very hydrated, as I said, then nothing changes. That is, the fluid remains at 100 milliosmolar, even though the fluid is passing through a very highly concentrated area. Water is unable to move by osmosis out of the collecting duct under these conditions because this membrane is impermeable to water movement. And we had talked in the other video about the ascending limb of the loop of Henle being impermeable to water. And this is a similar membrane. In this state, it's a similar membrane. Water can't move easily across the membrane on its own, and so the fluid remains dilute, and you produce a very dilute urine. And you know this is true if you are very hydrated, that your urine is quite clear, and that's the state of the hydrated person, which is signaled to the kidney by the lack of this hormone, which is called both antidiuretic hormone, or ADH, and vasopressin, Sometimes it's called arginine vasopressin. All of those are the exact same peptide with different names. And if you are quite hydrated, it will be suppressed. The level of that hormone in your body will be quite low, and this will be the situation in your kidney. Now, suppose that the opposite is the case. You haven't had anything to drink all day. You're very dehydrated. It would be unwise in a physiological sense for you to produce a large volume of urine because you need to retain that water in your body. In that case, changes in your body signal an increase, changes in your blood pressure and in the osmolarity of your blood, signal an increase in the hormone ADH or vasopressin. And so now you get a state, as is shown here, where again you start coming out of the distal convoluted tubule with very dilute urine, but in response to ADH or vasopressin, aquaporins or water channels have been inserted into the membrane of the collecting duct. So now water is permeable in this membrane, and it's not either permeable or not permeable. The permeability is going to be variable depending on the level of vasopressin. So if you're moderately hydrated right now, you'll have a moderate number of aquaporins in your collecting duct. Now, the aquaporins, of course, allow osmosis. So as the collecting duct dives down through the saltier and saltier part of the kidney, water will flow by osmosis out of the collecting duct and into that interstitial fluid, where it's then reabsorbed into these blood vessels. So as the fluid in the collecting duct moves down deeper into the medulla of the kidney, its fluid becomes more and more concentrated because water will keep leaving until it reaches equilibrium with the fluid in the interstitial fluid outside of that tube. And we know that that fluid can be as concentrated in your larger nephrons as 4 times as concentrated as blood, or about 1200 milliosmolar. So then the filtrate at the bottom of the collecting duct can itself become 1200 milliosmolar. It couldn't become any more concentrated than that, because if it were more concentrated, water would flow back into it from the interstitial fluid. An aquaporin doesn't have a directionality to it. But it could become as much as 1200 milliosmolar. And so when you're very dehydrated, you can produce a urine that's 4 times as concentrated as your blood, which typically is a very yellow and often almost stinky urine, right? And that retains the water that you need inside your body. So how concentrated the filtrate is at the bottom of the collecting duct depends on your state of hydration, and that signal is carried by the hormone vasopressin, so it's quite variable. But the conditions under which urine could be concentrated, that is, very concentrated interstitial fluid, are present continuously, and they're produced by the loop of Henle continuously, allowing the state that's possible for you to concentrate your urine. After the collecting duct releases its fluid into the renal pelvis, the contents of that can no longer be modified. So urine, what is now urine, once it's in the renal pelvis and no longer filtrate, retains that osmolality for the rest of the time that it's in your body. Okay, if you have questions about that, just let me know.